Hey guys, I've had a question about section 6.3, homework problem number 4. It says when two births are randomly selected, the sample space for genders is a boy and a boy and a girl and a boy, and then a girl and a girl. Assuming that those 4 outcomes are equally likely, construct a table that describes the sampling distribution of the sample proportion of girls from 2 births. Does the mean of the sample proportions equal the proportion of girls in 2 births? Does the result suggest that a sample proportion is an unbiased estimator of a population proportion? For the entire population, assume the probability of having a boy is 1/2 and the probability of having a girl is 1/2, and this is not affected by how many boys or girls have previously been born. Okay, so they first want you to determine the probabilities of each sample proportion. So the sample space is here. It's these 4 situations for 2 births. So if you look at this first scenario, you've got a boy and a boy. So what's the percentage or proportion of girls if that happens, if you have 2 boys? Well, that would be 0. So 0 in this first situation, you have 0% girls. You just have 2 boys. And what's the probability of that happening? Well, 1 time out of 4 scenarios. So that would be a 1 in 4 situation, or a 0.25 probability. Excuse me. Now, that's this first scenario. Now look at the next 2. If you have a boy and then a girl, what's the proportion or the percentage of girls that you have? 1 out of 2, which is 50%. Look at this third situation. You have a girl and a boy. Well, in this situation, what's the percentage of girls that you have? 1 out of 2, which is 50%. So the second proportion that you would choose in this table would be a 50% chance, or 50% of the children are girls in these 2 elements of the sample space. So what's the probability of you getting 50% girls? Well, these 2 situations out of 4 total possible situations. So 2 times out of 4, which is 1/2, which is 0.5. Okay, and then we get to the fourth scenario where you have 2 girls. Well, if you have 2 girls, then what's the proportion of girls in this situation? Well, it's 100% girls. So that would be 1. And you know, out of these 4 situations, when do you get 100% girls? Well, this 1 time out of these 4 scenarios. So 1 out of 4, which would be a 0.25, or 1/4. So that's how you set up the table. Now the second part, let's see what they ask you for. Does the mean of the sample proportions equal the proportion of girls in 2 births? Well, the proportion of girls in 2 births we know is 1/2. So let's look at the mean of the sample proportions. Well, the sample proportions are here. We've got 0, 1/2, and 1. And so they're asking you the mean of these sample proportions, or in other words, the average of these sample proportions. So 0, 0.5, and 1. So if you take those, 0, and you add that to 0.5, and you add that to 1, when you add those 3 numbers up, you get 1.5. Now again, the mean is the average, so you would have to, since there's 3 numbers here, you would divide the 1.5 by 3. And when you divide, 3 goes into 15 5 times, you will see that the mean of the sample proportions is 0.5. Okay, so when you go to choose your answer, does the mean of the sample proportions equal the proportion of girls in 2 births? Yes, both the mean of the sample proportions and the population proportion or 1/2. Okay? Yes. Okay, so then it says, does the result suggest that a sample proportion is an unbiased estimator of the population proportion? Yes, because the sample proportions and the population proportion are the same. Okay, so the proportion, the sample proportion is an unbiased estimator of the population proportion. I hope this helps you. Thanks.